To predict whether a precipitation will occur or not, we have to compare the value of the ionic product Q with the solubility product KSP. So remember, the Q expression is equals to the KSP expression, but the difference is for Q, the concentration is taken at any given time, but for KSP, the concentration must be the concentration at equilibrium. So, if the value of Q is smaller than KSP, it means that the soluble ions has low concentration in the solution, so the unsaturated solution will form, so there is no precipitation occurs. But if the Q is equals to KSP, the solution is saturated with its soluble ion, so no precipitation occurs. But if the value of Q is bigger than KSP, it means that higher concentration of soluble ions in the solution. So the solution is called supersaturated and the precipitate will form. Have a look at the example 1. Will a precipitate form in a solution if the Ca2 plus concentration, right, is 0.025 molar and the concentration of SO4 minus is 0.030 molar. So the KSP of CaSO4 is given as 2.4 times 10 to the power of minus 5. So this 2 is not the solubility of the CaSO4. So means that these two concentrations are the initial concentration. So since we have the initial concentration, we can calculate the value of Q. So Q is equal to concentration of Ca2 plus times with concentration of SO4 minus ion. Substitute the value, you will get 7.5 times 10 to the power of minus 5. And then compare the value of Q with KSP. Since the value of Q is bigger than KSP, the CaSO4 will precipitate until Q is equal to KSP. Example 2. Does a precipitate form when 0.100 liter of 0.30 molar calcium nitrate is mixed with 0.2 liter of 0.06 molar sodium fluoride? So the KSP for calcium fluoride is given. CaNO3 and NaF is a soluble salt. When these two salts are mixed, it will produce CaF2, the insoluble salt, and NaNO3. So there are 4 ions are present in the solution, which is Ca2 plus, NO3 minus, Na plus, and F minus. So the possible precipitate is the CaF2 because we have the KSP of CaF2 around here. To predict whether a precipitate will form or not, we need to find the initial concentration of Ca2 plus and also F minus ion. Since these two solutions are mixed together, the molarity of this solution is not 0.30 molar and 0.060 molar anymore. So we have to find the new concentration for each solution. So find the moles of the solution, alright, and then divided it with the total volume. Okay, since the total volume of 0.3, the number of mole of CaNO3 is 0.030 moles. So the new concentration is 0.100 molar. Since CaNO3 is a soluble salt, so it is completely dissociated into Ca2 plus ion and NO3 minus ion. So the concentration of Ca2 plus ion is equals to the concentration of CaNO3, which is 0.100 molar. Same with sodium fluoride. So find the moles of sodium fluoride and then divided it with the total volume. You will get the concentration of sodium fluoride is 0.040 molar. So NaF is also a soluble salt, completely dissociated into Na plus ion and F minus ion. So the concentration of F minus ion is equal to 0.040 molar. Since we already have the initial concentration for both ions, alright. So now we are going to calculate the Q. So Q is equal to the concentration of Ca2 plus times with the concentration of F minus to the power of 2. Okay, substitute the value. So you will get the Q is equal to 1.60 times 10 to the power of minus 4. Now compare the Q value with KSP. So since Q is larger than KSP, so the CaF2 will precipitate until Q is equal to KSP.